When it asks, are the three types of discontinuities present? And the answer for that is yes, because this one is a removable discontinuity, this one is jump, and this one is asymptote. For this one, you know it's removable because the limit exists. This one, you know it's jump because the limit does not exist. And this one, you know that there's an asymptote right here. So, yeah.
Okay.
All right, and the points are -2 with the open circle, 1 with the open circle, and then 4 because it goes straight up and straight down.
Go.
So number 3 says, if not, explain which type isn't present and state how to recognize the missing type from the graph, but all 3 types are present. So, yeah.
Okay, go.
And the domain of the function is 4 to 6, except for -2, 1, and 4.
So number 5 says, what is the range of the function? And the range of the function is from negative infinity to positive infinity. Okay, number 6 says, use the continuity checklist to determine if the function is continuous at x equals 1 and x equals -2. So I'm doing x equals 1. And to first figure out if it's continuous, first you know that it's not because there's an open circle. And then to figure it out algebraically, you first figure out the function of 1. So f of 1 is 2. And then you figure out the limit of the function. The limit of x equals 1. And from the left, it's -3. And from the right, it's 4. So we know that the limit does not exist, which also makes it discontinuous.
Okay, go.
All right, so right here is this continuous because you have an open circle, and f of -2 equals 5, and then the limit x approaching -2 is 3, and because those aren't the same, so you know it's discontinuous.
Okay. Action.
Okay, number 7 says, does f of -1 exist? And yes, it exists because f of -1 is 0.5. So if x is -1, y is 0.5.
And all right, so the function is defined at -2 because f of -2 equals 5, and that's how you know it's defined.
Okay.
Okay, number 9 says, state how continuity and domain are related. And they're basically related because they depend on each other. For continuity to exist, C has to be a point in the domain of the function, f of x. Then the limit of f of x as x approaches C has to equal f of C.
All right, so x is continuous when x is greater than 2/7, and to find that, we start with this 5 over radical 7x minus 2, which equals 7x minus 2, which is greater than 0. Then you got 7x, which is greater than 2, and then x is greater than 2 over 7.